Hello students, in this video let's solve first exercise of cubes and cube roots. First problem, which of the following numbers are not perfect cubes? So I already taught the prime factorization. So in the same way, this number, that is 216, it should be factorized like this. Okay, so this number, it's a multiple of 2. So 2, it's a prime number, so by 2 you have to divide this number. Okay, so 216, if you divide by 2 you will get 108. Okay, then again this number ending with 8, so this number 108 is also divisible by 2. So again divide 108 by 2. So that's why you are getting 54 here. Then 54, you are having an even number in the ones place. Then this number is also divisible by 2. So again divide 54 by 2, you will get 27. So this number 27 is not divisible by 2. So what's the next prime number? It's 3. So you have to check whether 27 is divisible by 3. Yes, it's 3 9s are 27. So you will get 9. So 9 should be divided by 3. Then 3 3s are 9 you will get. So 3 is written here. Then again 3 divided by 3 you will get 1. So this is how you have to do the prime factorization. So this can be written as 2 into 2 into 2 into 3 into 3 into 3. So if you see here, you can see that there is 3 set of 2 and 3 set of 3. Okay, so you can group it by grouping the factors in triplets of equal factors, that is 2 into 2 into 2 in one set and 3 into 3 into 3 in one set. So you will get 216 can be grouped into triplets of equal factors. So this is a perfect cube. Okay, so 2 into 3 equal to 6. If you do 6 cube, you will get 216. So 216 is the cube of 6. Then 128. So how you should solve? You should solve by the prime factorization. So like this you have to factorize. So 128 divided by 2 is 64. 64 divided by 2 is 32. 32 divided by 2 is 16. 16 divided by 2 is 8. 8 divided by 2, 4. 4 divided by 2, you will get 2. 2 divided by 2, you will get 1. Now you have to check whether you can make set of triplets. Okay. So if you see here, you can make 2 sets and 1 2 is left without any pair. Okay. So that means that this is not a perfect cube. So 128 cannot be grouped into triplets of equal factors. So we are left with 1 factor 2. So 128 is not a perfect cube. Then 1000. So by prime factorization, you will get like this. Okay. So your prime factors are 2 into 2 into 2 and 5 into 5 into 5. So you can make triplets of 2 and 5. Okay. So you can write it as 2 into 5 equal to 10. So 1000, it's a cube of 10. Then 100. So 100, if you factorize, you will get like this. So 2 into 2 and 5 into 5. So you cannot make set of triplets. Okay. So 100 is not a perfect cube. The next problem, find the smallest number by which each of the following number must be multiplied to obtain perfect cube. So here also they didn't say these are perfect cubes. We have to find, these are not perfect cubes actually. So we have to factorize and we have to find out which number to be multiplied with this number to make it into a perfect cube. Okay, so first factorize it. So you are having 3 into 3 into 3 and 3 into 3. So you have one triplet and one more is left without one factor. Okay, if you multiply one more 3 here, then you will get one more triplet. Is it not? So 3 cannot be grouped into triplet of equal factors. So we will multiply 243 by 3 to get perfect cube. So this number only is split and written in this way. So this number should be multiplied by 3 to get a perfect cube. Okay. 256. So first do the prime factorization, then group it. So if you group it, you are left with 2 factors and one more factor is missing. That means this number 256 should be multiplied by 2 to get a perfect cube. Next one is 72. So 72, it is prime factorized like this. Okay, so I am getting 2 into 2 into 2 and 3 into 3. So one more 3 is needed to make a set of triplet. Okay, so 3 cannot be grouped into triplets of equal factors. So 72 should be multiplied by 3 to get perfect cube. Then third problem, find the smallest number by which each of the following numbers must be divided to obtain a perfect cube. So in the previous problem we did what should be multiplied. Here we are going to find out what should be divided to get a perfect cube. Okay, so let's start with the prime factorizing. Okay, so here you are having 3 into 3 into 3 into 3 times, 4 times you are having 3. Okay, so you can make one set of 3 and one 3 will be left without a set. 3 cannot be grouped into triplets of equal factors. So we will divide 81 by 3 to get perfect cube. Okay, so here this left out 3 should be divided to get the perfect cube. Next problem is 128. So first do the prime factorizing, then group into triplets. So we find that 1, 2 is left without the group. So that 2 should be divided to the number 128 to get the perfect cube. Okay, so if you want to check, you can cross check. So 128, if you divide by 2, you will get 64. Okay, so 64, it's a cube of 4. So then only you can get the perfect cube. Then 135. So first do the prime factorizing. So 3 into 3 into 3 into 5 you will get. So 3 can be grouped into one set and 5 is left without the grouping. So that 5 should be divided with to the that means 135 should be divided by 5 to get the perfect cube. Then fourth problem, Parikshit makes a cuboid of plasticine of sides 5 cm, 2 cm, 5 cm. How many such cuboids will he need to form a cube? So in this problem, this Parikshit, this boy is using a cuboid of sides 5 cm, 2 cm and 5 cm. So he have to make a cube out of this cuboids. Okay, so first let's start. The side of cuboid is 5 cm, 2 cm and 5 cm. And what is the volume of a cube? Volume is you can find it by the formula. Okay, so it is multiplication of all sides. Okay, so it is 5 into 2 into 5. That is volume of the cuboid actually. Okay, but we need cube now. Okay, understood. The boy is having cuboid and we need to design a cube. Okay, so here why we are multiplying means in order to find the volume. Okay, so the volume we got is 50 actually. But this is not a cubic number. Okay, so 50 is not a cube number. So we have to make it into a cube number to get the volume of the cube. Okay, don't confuse. Actually, he is having a cuboid, and we need to find the volume of the, volume of the cube. Then only we can know that the thing he have produced, it's a cube. Okay, that's why we are using cube here. Okay, actually first he is having cuboid only. Okay, so that's why first initially it is cuboid. He is going to add some more cuboids to make it into in the form of cube. Okay, so first one cuboid volume we got it to be 50. That's not a cube number, so we have to change it into a cube number. So here 2, 5 and 5 cannot be grouped into triplets of equal factors. Therefore, we will multiply 50 by 2 into 2 and into 5, that is 20, to get the perfect cube. See, if you see here, we are having 1, 2 and 2, 5. So, how to make it into a cube number? If you multiply with 1 more 5 and if you multiply by 2 more 2, then we will get set of 2 triplets and 5 triplets. Okay, so that's why 2 2s, 2 into 2 and 1 5 is missing. So 1 5. Okay, so 2 into 2 is 4, 4 5s are 20. So if you multiply 50 with 20, we will get a perfect cube. Okay, so what number you are multiplying, that is only the how many cuboids you are needed. Okay, so 20 cuboid is needed to make cube out of the cuboid with which he was first having. Okay, so that's all for this video. Thank you, children.